Good morning. Let us study today what are the factors influencing adsorption. What are the factors affecting adsorption? There are four well-known factors affecting adsorption. They are temperature, pressure, nature of gas molecules or nature of adsorbate, nature of adsorbent. The magnitude of adsorption or the amount of adsorption depends on the following factors, following four factors. Let us study one by one. Effect of temperature. Adsorption is a reversible process. Is a reversible process. The forward process is called adsorption. The reverse process is called desorption. Desorption. Adsorption is an exothermic process. During adsorption, heat is released. Delta H is negative. So it is adsorption is accompanied by release of heat or evolution of heat. According to Le-Chatelier's principle, what is called Le-Chatelier's principle? We have studied in chemical equilibrium. According to this principle, when the equilibrium system is disturbed, the system will go either in forward direction or in backward direction, so that the stress you applied is nullified. To nullify the stress, to nullify the changes, it either goes in forward direction or it either goes in reverse direction. Okay. For example, increase in temperature. Let us increase the temperature. We are doing stress according to Le-Chatelier's principle. Increase in temperature. See, already in the forward process, adsorption process, heat is released. Increase in temperature, increase. So the equilibrium will shift in the reverse direction so that the increase in temperature is nullified. Therefore, according to Le-Chatelier's principle, increase in temperature favors the reverse desorption process. Therefore, increase in temperature decreases the adsorption, where X by M is the amount of gas adsorbed per unit area of the unit mass of the solid substance. Okay. The adsorption decreases, decreases with the increase in temperature. Okay. This plot is called adsorption isobar. We will see further. Let us study effect of pressure on the adsorption. During adsorption, gas pressure decreases. Due to adsorption, the pressure of the system decreases. The pressure of the system decreases because of adsorption. Okay. So let us apply Le-Chatelier's principle again. Increase in pressure decreases the pressure. Therefore, according to Le-Chatelier principle, increase in pressure increases the adsorption, so that the pressure is decreased. To nullify the increase in pressure, absorption occurs when the pressure is increased. So increase in pressure increases adsorption. As you see here, adsorption isotherm, we will explain further, where X is the amount of the variation of X by M, the variation of adsorption with respect to the increase in pressure at constant temperature is called adsorption isotherm, where X is the amount of gas adsorbed and M is the amount of adsorbent, amount of solid substance taken. Let us study here what is called adsorption isotherm. What is called Freundlich adsorption isotherm. At constant temperature, The variation of adsorption with the increase in pressure is known as adsorption isotherm. Each curve is called adsorption isotherm. What is isotherm? Iso means constant temperature. So at constant temperature, the changes in adsorption with the increase in pressure is plotted called adsorption isotherm. This is at lower temperature and this is at higher temperature. At lower temperature, adsorption is greater. We have already seen increase in temperature. For example, increase in temperature decreases the adsorption. This is the adsorption at lower temperature, T1. It is higher. At higher temperature, the absorption decreases. So here this is the amount of gas absorbed by M. Okay, now let us see what is called Freundlich adsorption isotherm. This Freundlich adsorption isotherm gives the relationship between amount of gas absorbed or adsorption and pressure. This gives the relation between X by M, amount of gas absorbed, and the pressure of the gaseous in the system. The relation between X by M, the amount of gas absorbed and pressure, is expressed mathematically by an empirical equation. This is an empirical equation obtained from experiment by carrying out the experiment. This is the experimental graph. This equation is obtained from this. Each curve is mathematically represented by this curve. For example, a straight line is represented by y equal to mx plus c. Each curve is mathematically represented. This curve, adsorption isotherm, is mathematically explained by using this equation called Freundlich adsorption isotherm. This equation was obtained by Freundlich, so it is called Freundlich adsorption, where k and n are constants. N is always less than 1. N is always less than 1 in this. In the previous slide, we have studied adsorption isotherm. Now, what is adsorption isobar? At constant pressure, this is iso means constant, bar means pressure, at constant pressure. Therefore, the same definition at constant temperature, here at constant pressure, here the variation of adsorption with the increase in temperature is plotted, known as adsorption isobar. With the increase in temperature, adsorption decreases. We have already studied. Okay, this is explained by using adsorption isobar. Now let us study adsorption isoster. What is adsorption isoster? In adsorption isoter, there are three factors actually: pressure, adsorption, and temperature. In the first adsorption isoter, temperature is constant. Temperature is constant. In this adsorption isobar, pressure is constant. Another one is adsorption is constant. Here at constant x by m, or for fixed amount of adsorption, fixed amount of gas absorbed, constant x by m, the variation of temperature with the pressure for fixed amount of adsorption is plotted, known as adsorption isoster. So for fixed amount of adsorption, with increasing temperature, adsorption increases. Therefore, the pressure is increased to keep the amount of gas absorbed constant. So this graph is called adsorption isoster. The third factor is nature of adsorbent. There are two types of gases. They are permanent gases, easily liquefiable gases. Permanent gases are not easily liquefiable gases. Permanent gases are not readily absorbed, whereas easily liquefiable gases, SO2, ammonia, HCl, carbon dioxide, or they are easily liquefiable gases. They are easily absorbed. They have greater adsorption power, greater adsorption capacity due to high van der Waals forces of interactions between the adsorbate and the adsorbent. Okay. The fourth factor is nature of adsorbent, nature of solid surface, nature of solid sample. Adsorption, we know that adsorption is a surface phenomenon. So, greater the surface area of the solid sample, then greater is the adsorption power under the given conditions of temperature and pressure. For example, when the solid sample is finely powdered, when the solid sample is finely powdered in polycrystalline state, the surface area or in amorphous state, the surface area is greatly increased. Therefore, the adsorption increases very, very greatly, very much. Okay. Thank you for watching.